Hello everyone, welcome to your favorite YouTube channel, My Project Ideas, where we are gonna make your coding journey really smooth and exciting. I am Simran and welcome to the DSA course of My Project Ideas, where today's topic is gonna be prime factors. So without much delay, let's look at what prime factors means actually. How do you find out the algorithm? What is the time complexity? What is the space complexity? And how do you write an efficient solution for the prime factors program? Here we. So what is a prime factor? I hope many of you already know, but if someone has any doubt, then no worries. Here you are, just be with me. A prime factor is a factor of a given number that is a prime number. Suppose if you want to find out the prime factors of suppose 2 or suppose not 2 exactly, we can say 4. So what do you say? The prime factorization becomes 2 into 2. So you say that the prime factors are 2. Factors are numbers when multiplied together produce the original number. Like if we want to find out the prime factor for the number 4, so if you multiply the prime factors, you get 2 cross 2 or 2 multiplied by 2, and 2 multiplied by 2 gives you the original number, that is 4. So what are the prime factors for 4? That is 2. What is prime factorization? It's the process in which you write down the prime factors. And suppose, for example, if you take the example of 6, so the prime factors are 2 and 3, and if you write down the prime factorization, it becomes 2 cross 3. So how do you find out the prime factorization? Like 6 divided by 2, you get the answer 3, and 3 again divided by 3, you get the answer 1. So just continue the division until you get the answer 1. And the number which you are dividing, that becomes the prime factor. And multiply all those numbers, you get the prime factorization. Got it? Next. What are some of the interesting factors about prime factors? Some interesting facts, some less known facts. So what's unique factorization? So every number basically has a unique set of prime factors. And this law is called as fundamental theorem of arithmetic. That is not required exactly. But if you want to know, if you want to like dig deeper into it, you can obviously. And this PPT will be provided to you so you can have a look. So this Pollard's algorithm is not required. Pollard's algorithm. It's basically for your information only. And these applications basically to find out the divisibility of a number, if one number is divisible by other, to simplify the fractions, because suppose if someone says you 125 by 1000, so you can again divide it by 25. So again you suppose for simplicity we can take 2 by 4. So it can again be divided by 2 and you get the answer 1 by 2. So that's it. Then to make common denominator so that you can perform the operations like addition, multiplication, subtraction, etc. Okay. Basically for adding or subtracting fractions, multiplication you can do that like that only. So for addition and subtraction of fractions, you require common denominators. You take the LCM, you do cross multiply, and then you solve this stuff. You're getting now what I'm saying? So that's what. Then how to print the prime factor of a number? If you want to get to the prime factor of a number and if you want to follow the naive solution, so you have to write a function to print the prime factors for n. Suppose if a number is 12, output will be 223. If a number is 315, it should be 3357. So what are the steps? So if n is divisible by 2, you have to print 2 and divide the n by 2. Okay, I said you when I was explaining about the prime factors. Then if after step 1 your n is odd, you have to start a loop from I is equal to 3 to the square root of n. Similarly, how did you find if to check whether the number is prime or not? The same logic you are using here, but you are just using the factors of that. Okay, if n is a prime number and is greater than 2, so n will not become 1 by the above two steps. So print it if n is greater than or equal to 2. So what it says is, suppose you are finding out for a number 15. So what do? So 15 basically you first iterate a loop from 3. So for 15 it will be divided by 3. So you get the answer 3 as a prime factor. You store it in a array. Then you get the answer as 5. then 5 will be divided by again 5. So then you get the answer, or the what do you call, the quotient as 1. So the number which you got are 3 and 5. So 3 and 5 are the prime factorization. 3 cross 5 is the prime factorization of the number 15, and 3 and 5 are the prime factors. Got it? So we are going to code in two possible ways, and the time complexity of them will be big O of square root of n, and auxiliary space will be big O of 1. All of your doubts will be cleared here while we write the code. So I already tell you the algorithm. You can pause this video for a second and try to write down the code by your own. And people who are not able to understand the algorithm, who did not understand the algorithm, no worries. Just be with me. We are going to code it together. So let's move to the code section here. So we have, for the knife, let's import math because we are going to use the square root function. Then let's define a function called df prime factors, parameter given n. So now we are going to print the number of 2's that divide n. So how do you do it? While n mod 2 double equal to 0, I need to print 2 and your n equal to this. Because we are gonna have a space as we are displaying the prime factors. You can put comma also, no worries. And let's do the integer division. Okay, good to go. Then let's begin another loop here. Missed out the indentation. No issues. For I in range starting from 3 till end, math dot square root of n plus 1, and let's put a comma and let's put it. Why we are writing this is, so at this point n must be odd, so we can just skip one element and we can like do it as I is equal to I plus. The increment values can be by 2 because we have got an odd number at this point. Okay, then let's see if your number divides a particular I or not. Yeah, I mod I is double equal to 0. Then what do you do? Print I, and again you have to separate it by space or comma events. I am separating it by space, a single space. Then again modular division I. Okay. Next, so this is one condition which we covered. Now let's cover that condition where the prime number is greater than 2. So again, let's write a conditional statement here. If n is greater than 2, what we are going to do? Print n, comma, n is equal to. Now it's time to write the driver program. Okay, so n is equal to, I have taken a number 315, and let's call the function prime factors. Let me save it and let's run. So you got the prime factors as 3357. When you multiply it, you get the number 315. Okay, so 3 cross 3 is 3 into 3 is 9, 9 into 5 is 45, 45 into 7 is 315. Got it? So this was your knife, and let's do another efficient solution. Let's get a file. Efficient dot. Now let's write down another code. And if we can alter, or if we can approach it in a different way. So let's write the function def print prime factors, the parameter n, was some blockage. It's not able to write. My laptop hanged for a second. If n is less than equal to 1, then let's return. Now we are gonna check, print the number of 2's that divide in. So we are gonna check that whether the number of 2's that are divided by n, we are gonna print it. So let's write the condition while n mod 2 is double equal to 0. Then what we need to print it? Print 2 comma n equal to the space given here. Next, modular division divided by 2. Then number of 3's we need to find out. Same thing, copy it, copy, paste it here, replace the 2 by 3, replace it by 3, and replace it by 3. Okay, next, start from 5 because 2 and 3, that's 2 and 3 case has already been taken care of. Now start with 5 while I is equal to, sorry, it's I multiplied by I square actually, because I'm not taking your square root, because see, I have not imported math here. So I'm not taking square root, I'm just doing it in a different way. I'm doing the multiplication twice. So the power I'm using, square I'm using, not square root here. Then while n mod I is double equal to 0, then we need to have a printing statement which says prints I, and again the end will be space. Okay. Next, let's modular divide it, this time by I. Next statement, while n mod I plus 2 double equal to 0, then print again, have a printing statement again, I plus 2 comma and is equal to space. Then write down the condition, or the, not the condition, the decrement value. So again it is a division, I plus 2, because we started from I plus 2 here. Next, incremented, we did this before in the prime factors number in the efficient solution. So can you tell me how am I gonna increment the value, by which number? It's by 6. Then now the next case will be for handling a prime number which is greater than 3. Okay, right from here, if n is greater than 3, what do? Print n, simple, print n, and your end will be this. Now what we have to do, guys? We have to print a new line just to make it look good. Then the number we have 315, and let's call the function print prime factors, and let's give the parameter as n. We're done. Let's run it. Should run fine. Okay. There is, the terminal is not clear. Let's run it. So you get it as 335. So I hope you understood the prime factors concept properly. What were the prime factors, the time complexity, what is the algorithm. We again wrote the 2 different approaches. I hope it was clear to you. Now let's wrap this session for today. And still then, stay tuned, keep learning, keep coding. Bye bye guys, I'll take your leave. Thank you.